Yet. Okay, we are going to the classwork, but not yet. We're going to start in your notebook. So right there under, grab one off the top. So right there under notebooks, you are going to your, that usually like clear out your sinuses a little bit. We are going to solving equations notebook. You'll know you're in the right, you know,
that's so good.
You'll know you're in the right place. All right. I'm trying to tell you important stuff. You'll know you're in the right place if it looks like that. That's your title page. But we're scrolling over to page 4. So we're starting off in the notebook. So you know you're in the right spot if it looks like this. But you're scrolling over to page 4. That's where we're going to actually start writing. I'm going to give everybody a second to get there. Scroll over to page 4. So we should all be on this page right here. In case you can't tell, okay, so our learning target, solving 1 and 2 step equations. I know, especially based on the map testing we did, a lot of you guys know how to solve a 1 and a 2 step equation, okay? So before you roll your eyes and you're like, oh my gosh, why are we doing this? There's a couple of, you can see that I wrote most of it out for you. All we need to do, so you can see that I've written out most of it for you. We are not going to spend a lot of time writing this down. All we need to do is write down a few things because there's a few vocabulary words and terminology for certain things that your middle school teacher might have called it one thing. So we want to make sure we know what those, like what the, the big kid words for this stuff is. So we're not really writing a lot. We're just kind of filling in some blanks here. So we started on Thursday writing equations. Remember, don't worry about the Friday classwork. I've decided to skip it. This is actually more important, which is why we're just going to go ahead and move on. And so when you're solving an equation, remember you're trying to figure out exactly what that variable is worth. So like a visual that we give a lot in middle school is, imagine you've got the variable. It balances out. It's kind of like a little balance scale. So x is equal to 3, right? All right. Now, in order to be able to find out how much a variable is worth, I've got to get that variable all by itself, right? If I want to see how much I weigh, it doesn't make any sense for me to stand on the scale holding my kid or my cat or whatever, okay? So we're going to add our first text box. We're going to do this page real quick. To get the variable by itself, the term for that, who's a middle school teacher was a rock star? What's the big kid word for getting the variable by itself? Starts with the I. Isolated. Yes. So we're going to add a text box right here. That is called isolating the variable. Yay. Great.
I don't. This is easy. Okay. My middle school teacher sucks.
Hey. Well, now that's recorded for all of posterity to hear. There are some good Westport teachers. Personally, I've been very isolated. I'm terrified we're going to have to go back into shutdown again. I'm going to cry if it's just me and my kids stuck at home all day because I feel very isolated. I thrive on like interaction, so I'm a little stressed that I'm going to be isolated again. Now, all of the equations that we're going to be doing for the next several weeks do not start off with an isolated variable. They're going to start off with a whole bunch of crap. Today we're going to start off more simply and build, but bottom line, they're not going to be isolated right from the get-go. We're going to have to get rid of what is with the variable. And the procedure we do for that, we're going to add another text box here. Oops. So we're going to add another text box here. If a variable is not isolated, you need to do it by using something we call inverse. I know you've heard this word before, right? Operations. Inverse is another word for opposite. So if the equation has addition in it, you're going to use subtraction to get rid of what's with it. If the equation has multiplication in it, you're going to use division. You're going to use the opposite to like undo that equation. Don't worry, we're gonna do actual examples in a minute, but right now we're just kind of getting the terminology down. Now, we all know Hopefully we know. I know there's not a middle school teacher in America that has not said this before. What you do to one side, you have to do to the other, right? If you don't, your equation ends up like this. It ends up jacked up because you did something to one side, but you didn't balance it out. So the big kid word for what you do to one side, you have. I never hear people that know this. Maybe I'm wrong. Does anybody ever, do we know the big kid word for what you do to one side, you have to do to the other?
Oh, yeah.
I haven't run into anybody that's known it today.
I know it. Oh, God.
It's all right if you don't remember. It's okay. These are called the properties of equality.
I thought it was the reciprocal. Never mind.
Ooh, we're going to talk about reciprocals in about 3 days.
Oh, so I'm ahead of this. Oh, wow.
So, 3 big ideas. You're getting the variable by itself. That's called isolating. You get it isolated by using inverse operations, using opposites. And what you do to one side, you have to do to the other. Otherwise, your equation is jacked up. And we call those properties of equality. So these are the terms. Now let's look at some examples and putting that in action now. I will go back to this if anybody's still typing, but I'm going to go ahead and go on to page 2. So we can actually look at an example, or page 5, I guess, is what it is in your notebook. So flip over to the next page if you need to. Okay. All right. So a lot of people think that means subtraction because there's a -5 sitting there. That's not what the operation is that's sitting there in that equation. That equation has a -5 sitting next to the n. So what operation does it mean when you've got something just sitting next to the variable? Yes, ma'am. That is multiplication. So this equation contains multiplication. This one we've pretty much raced through in every class. It's the next 2 that kind of gave us a little bit. Ooh, that's kind of ugly, but we can read this as multiplication, right? So this equation has a -5 sitting next to the n. That means that we're multiplying. We're going to have to get rid of that -5 because we need the variable by itself. So we have to do the inverse of multiplying. What's the inverse of multiplying? Division. Correct. Now, we don't use a little baby division symbol. We use a fraction bar, which is what I'm going to do right there. So I'm going to cancel out that -5. Yeah, to do the little fraction bar, if I were you could use the little pen tool and just kind of jot one down. Or if you want to use a text box, you can do the little front slash, a -5 that way. And just drag it underneath. Either one's fine. So you can use the little pen tool, or you can just add a text box and the little front slash. And then last but not least, if you do it on one side, you must do it on the other side. The inverse operation must be done on both sides according to, and we're going to fill in this blank, it's called the division property of equality. That is just the big kid word for saying, hey, I divided the right-hand side by -5, so I'm going to have to divide the left-hand side by -5.
No, Dr. P.P.
Okay, so what happened here? So this 5 and that 5 cancel each other out, right? So now we're simply left with that isolated n like we needed. We've got our equals, and then 30 divided by -5 is -6. So this one, every class today, we've pretty much whizzed through. What's in that equation? You're multiplying, because the -5 is sitting next to the variable. How do you cancel out multiplication? You do that by division. And why do we have to do it on both sides? Because of that division property of equality. And yes, Mikey, I get it sounds stupid. It's like, why do we need to know that exact word? Because, again, on those standardized tests and stuff, you're probably going to see it.
Dude said so.
Exactly. Division property of equality. And there's an addition property of an equality. There's basically one for everyone. Example 2, there's a misconception that a lot of kids have for middle school that I want to talk about with example number 2. So first of all, let's identify what operations are in that equation. That fraction bar means what? Division, exactly. So this equation contains division. And we are adding a 5, right? So we've got division and addition. Okay, step 2. Now that we've identified what the operations are in there, we've got to determine what are the inverses. So the inverse of division is, of course, multiplication.
Mikey's weird. What? Oh, you got that on recording.
I know I do. Shh. You're being bad for my ADHD too, even though I love you. Okay. So the opposite of division is multiplication. The inverse of addition is, of course, subtraction. And you can really just copy and paste. That's what's kind of nice about ClassKick. Because you've got these 2 words already typed, you're really just going to copy and paste them right down here. The reason we have to do it on both sides is because of the multiplication property of equality and the subtraction property of equality. So you don't need to write it down twice. You can literally just copy and paste it from up there. So why do we need to do it on both sides? Because of the multiplication property of equality and the subtraction property of equality. But you really can just copy and paste those text boxes. That's one thing that is nice about ClassKick. If you got to make something repetitive, you can just copy and paste. All right, so this is the part, the reason we're doing this part, or we're doing this particular example, is because maybe I'm wrong. In one class so far, I did have a group that kind of proved me wrong a little bit. But mostly, people have a misconception from middle school. I'm going to zoom in here for a second, and I'll come back. How many of you guys had a teacher that told you, you got to get rid of that extra guy first that's kind of off there to the side, and then get rid of whatever's with the variable? Okay, I see a lot of nodding. Okay, no offense to middle school teachers, none whatsoever. I was one for 12 years, but that is not correct, okay? It doesn't really matter today, but it is going to be a very important concept in a few days, especially when we start doing fractions, okay? And that is exactly why I wanted us to do this specific problem. So if you look at the notes where I have here, it says the inverse operations can be done in any order. You just have to be careful. I'm going to show you both ways. You just choose whichever way you want to write it down, but I am going to show you both. A, so it's on this recording for everybody that's at home. B, so that you can see that you get the same. And it's really not important today, but it will be important in a couple of days. Okay? So I'm going to do it the way that most teachers are going to tell you to do it first, which is to deal with that 5 first. So how am I going to get rid of that positive 5? I'm going to do it by doing a minus 5. And because of the property of equality, I've got to do it on both sides, right? So those 5s are going to cancel and leave me with m divided by 2. On the right-hand side, we've got 1 minus 5, which is negative 4. Now, how are we going to cancel out dividing by 2? What's the inverse of dividing by 2? Multiplying by 2, right?
I was going to say that, Mikey.
Okay.
Negative 8.
So here's something I see wrong a lot. If you guys see me write something in red, it's incorrect. I see a lot of people multiply these. Okay, we're not multiplying that. The whole point of multiplying both sides by 2 is because dividing by 2 and multiplying by 2, cancel each other out, right? So that's just going to leave me with an m. And then, Mikey, you're correct. M is equal to negative 8. You do not need to write down the second way I'm doing it. I just want to show you that you can get the same answer by doing it correctly or by doing it in a different order. Okay, so I'm going to rewrite it over here. but I'm going to show you how you can solve the same equation by doing it, in a different order, but still get the same answer. So here's where you have to be careful, though. If you multiply or divide, you've got to make sure that you multiply or divide everything, okay? So I'm going to multiply everything by 2. Okay. So 2, 2, 2. So 2 times 5, what am I going to get when I do that? I'm going to get 10.
Wait, is this the way we should do it, quote unquote?
Nope. You could actually, either option is correct for this. Now, in a couple of days, you're going to want to do it this way, but you don't have to. I'm just showing you it works.
But isn't the first one, easier?
It will not be easier in a few days.
Oh.
Today, like I said, today, it doesn't matter. Will it in a few days, though? It's going to matter. You're going to care. So then we subtract 10 from both sides.
Define a few days.
So see how no matter what, you're being really bad for my ADHD right now.
Okay.
So no matter what, you end up with the right answer. That's going to be important later. Okay, so you notice the difference between example number 2 and example number 3? Both have a denominator, but notice in example number 2, it's just the variable that's over the 2. In example number 3, everything is above the denominator. You see that? You've got the variable and a number. So a lot of this is repetitive. You can probably copy and paste. So we have division. And we are adding, for our other operation, we're adding a -9. So this equation has division, and you're adding a -9. I'm going to fast forward through this because I know that we know the inverse of division is multiplication. What's going to be the inverse of a -9? We're going to do what's the opposite of adding a -9?
Subtracting a positive 9?
Yes, which is the same thing as adding a positive 9. You agree with me?
Yeah.
Yep. And you can pretty much copy and paste what you just wrote here. We have to multiply on both sides because of the multiplication property of equality. So you can just copy and paste. I'm being repetitive because I really want us to remember that term. It really will pop up at some point. So it's repetitive, but you're going to need to know that. So we've got division. We're adding a -9. We're going to do the opposite, which is multiplication, and adding a positive 9. Now, as opposed to the previous example when it didn't matter what order you did it in this example, order matters, okay? And this is why I don't like how middle school teachers tell you, hey, get rid of this guy first, because you can't get rid of that guy first. Until you get the 3 out of that denominator, you cannot get rid of that 9. In this particular case, you have to multiply first, because you've got to get that -9 and that m, they're like trapped on top of there for right now. So what you're going to have to do is multiply by 3. And here's the other mistake I see kids make a lot. This is in red, so it's wrong, right? Don't multiply. A lot of kids will multiply that 3 by -9. You're not going to do that. Okay, this 3 and that 3 cancel each other out. So you don't have a 3 to multiply that -9 and that m by. Okay, so don't multiply. That 3 cancels each other out. So all you've got left now is that -9 plus m. Of course, what you do to one side, you know you need to do to the other side. So you've got -9 plus m is equal to -9. And last but not least, we got to cancel out the -9 with a +9. So m is equal to 0. So in a case like example 3, you don't have a choice. You have to multiply first. That's why I don't like how middle school teachers drill in your head, like, get rid of the extra number first. No, not necessarily, because sometimes you can't. Sometimes you cannot get rid of that one first. All right, so those are the only